NASA develops radiation shielding technologies for Mars missions. The journey to Mars is a long and dangerous one. Astronauts will be exposed to high levels of radiation during the trip, and this radiation could pose a serious health risk. Outside the protective cocoon of the Earth's atmosphere is a universe full of radiation. The space between Earth and Mars is filled with high-energy particles. Space radiation is composed of various types of energetic particles that originate from different sources. Let's break down what radiation really is. The primary sources of space radiation include solar radiation, cosmic rays, radiation belts, and secondary radiation. Let's move on to the solar radiation. There are two types of solar radiation. First on our list is solar wind. The sun constantly emits a stream of charged particles, mainly electrons and protons, known as the solar wind. While the Earth's magnetic field provides some protection from the solar wind, spacecraft traveling beyond this protective shield are exposed to a higher intensity of solar particles. Next up, there are solar flares. These are sudden and intense release of energy on the sun's surface. Accompanied by bursts of high-energy particles, including protons and heavy ions. Solar flares can significantly increase radiation levels in space for a short period. Second source of space radiation is cosmic rays. There are two types of cosmic rays. First is galactic cosmic rays. These are high-energy particles, primarily protons and heavy ions, originating from outside our solar system. They come from various sources, such as supernova explosions and other energetic events in the Milky Way and beyond. GCRs constantly permeate the interstellar medium and can penetrate the heliosphere, reaching our solar system. Second is solar energetic particles. These are particles accelerated by solar flares and coronal mass ejections. While solar flares release particles in a short burst, coronal mass ejections can release larger amounts of particles over a more extended period. Third source of space radiation is radiation belts. The Earth has two radiation belts known as the Van Allen belts, which contain charged particles trapped by the Earth's magnetic field. While these belts mainly affect low Earth orbit missions, they can pose a radiation hazard to spacecraft passing through them. Fourth and last source of space radiation is secondary radiation. When primary cosmic rays or solar particles interact with spacecraft materials or the Earth's atmosphere, they can produce secondary radiation, including neutrons and other particles. These particles can penetrate human tissues and damage DNA, which can lead to cancer and other health problems. NASA has explored various approaches to mitigate radiation risk for Mars missions. Some of the strategies and technologies under consideration include material shielding, biological shielding, structural design, and innovative technologies. First is material shielding. Researchers are exploring various materials with high atomic number and hydrogen content, as these elements are effective in attenuating different types of radiation. Hydrogen, in particular, is known for its ability to absorb and slow down charged particles. Composite materials, which combine different substances to enhance their shielding properties, are being studied. These composites aim to maximize radiation absorption while minimizing weight, as reducing spacecraft mass is critical for space missions. Second is biological shielding. Water is a promising candidate for biological shielding due to its high hydrogen content. Water can act as a natural barrier to radiation and is already being used in the design of spacecraft to provide some level of protection. Other biological materials such as polyethylene have also been investigated for their potential to serve as effective shielding against certain types of radiation. Third is structural design. Engineers are incorporating radiation shielding into the overall structural design of spacecraft. This involves strategically placing shielding material to protect crew compartments and critical equipment. The design of spacecraft includes considerations for the arrangement of living and working spaces, with an emphasis on placing these areas behind shielding materials. Fourth is innovative technologies. There are two innovative technologies. First is magnetic shielding. Magnetic fields have the potential to deflect charged particles, providing a form of magnetic shielding. Research is ongoing to explore the feasibility and effectiveness of using magnetic fields to protect astronauts and spacecraft from radiation. Second is electrostatic shielding. This involves using electric fields to repel charged particles, creating a form of electrostatic shielding. Similar to magnetic shielding, this technology is in the early stages of research and development. Well, folks, that brings us to the end of this journey into the NASA's latest developments in radiation shielding technologies for Mars missions. I hope you have enjoyed learning about the incredible innovations that are paving the way for the future of space exploration. From advanced materials to cutting-edge designs, NASA is leaving no stone unturned in ensuring the safety and success of human missions to the Red Planet. The dedication and brilliance of the scientists and engineers behind these projects truly inspire a sense of awe